Good evening, ladies and gentlemen. Good evening to all our online users. Today we are going to start our second discussion on telecommunication stream. So we successfully conducted a discussion on 5G, and today we are going to take another very exciting and very important and useful topic for our discussion, generative AI. We are very privileged to have two distinguished personnel for this discussion. One is Dr. Damayanti Herath, Senior Lecturer in University of Peradeniya, Department of Computer Engineering. And during the course of time, Dr. Sharman will also join with us from USA. And I think both of them have done an immense contribution and research to develop this area, and they are actively working in this area to reach the researchers and the outcome of the same. So Electrical, Electronic and Telecommunication Engineering Section Committee is very much privileged to welcome Dr. Damayanti Herath and Dr. Sharman for this discussion. So without taking much time, I would like to give the floor to Dr. Damayanti, who will going to start the session, and then she will work with Dr. Sharman to conclude the session. So thank you very much, Dr. Damayanti, for accepting our invitation, and we would like to hear from you from now onwards. Thank you very much.
Right. Very good evening, everyone. First of all, thank you so much. Thank you so much for this opportunity for me to talk to you. Ones who are joining physically over there at Mavis Studio, as well as ones who are joining online. And as was mentioned, I'm a senior lecturer at the University of Peradeniya. So, and I'm attached to the Faculty of Engineering, and often I talk with engineering undergraduates. So I think I take it as a privilege that I got an opportunity to talk to people out there in the industry on this topic. And going forward, yeah, so let's, before starting the talk today, let's move back around 2 decades before in time. And in around 1990s, what we saw was actually with the invent of internet, we saw a huge focus of industry around solutions based on the internet. Things like Google suggesting this amazing tool for search, Amazon suggesting this tool for logistics management, for online trading, etc., buying and selling with the internet. And then if we fast forward to around 2005 or so, what we saw was with the advent of smartphone and around technologies, we saw another wave of solutions, another way of industry coming into the picture. So we saw things like Uber in Sri Lanka. Now we see things like PickMe and Airbnb and TikTok, very interesting applications. But now coming back to where we are today in 2024 or 2020s or so, I saw someone raise hand. Hope there's no issue. You can hear me and see my screen, right? Yeah.
Dear audience, we can give you the opportunity to raise question at the end of the session. If you have any issue, just type on the chat. Let's give the opportunity to Dr. Damayanti to conduct the session. And meantime, we can get the questions. Thank you very much.
Yeah, thank you for that. So coming into where we are standing today, nowadays, I think the very reason that I was invited to talk about this topic is now we are seeing another wave of solutions, technologies coming up with artificial intelligence. But so now we see, if you look at this, we are very frequently hearing about the term artificial intelligence. Especially, we are very frequently hearing the term generative artificial intelligence or the generative AI. And this infographic is coming from around last week regarding the most popular AI tools of 2023. And before I go forward, I would like to ask, of course, and I should mention that I'm going to make it as interactive as possible because this is a Monday evening, 5:30. We are just starting the week. If it is just going to be 1.5 hour a lecture, that's not going to be that helpful for both of us. So I would like to make this as interactive as possible. Anytime you can stop me, ask questions, interact with me. So as this infographic shows, the most popular AI tools of 2023 had been ChatGPT. So I would like to ask the natural question, if you can please give a raise of hand. How many of you are already using ChatGPT? I see 1 hand, 3 hands, 5 hands, 6, 7. Let's ask another, maybe an. And I'll also ask the question, how many of you are not using ChatGPT at the moment? How many of you are not using at the moment? Okay, I think we all get the picture now. Looks like majority of us, if not all of us, are using this tool called ChatGPT. And also we see some very famous, very popular generative AI tools these days, like Midjourney, Quillbot. It's not really a generative AI tool, but now it has generative AI integrated into the application, and things like Bard, and character AI, maybe it's not that popular in Sri Lanka, but it's also among the most popular AI tools in 2023. So interestingly, I have been now today been invited to talk about this topic, generative AI tools. As you can see, I'm talking in from my office space at University of Peradeniya, but I wish we could have it at the Peradeniya itself physically, and I could show the beautiful nature around me to you. This is, in fact, the view from my window. Why I thought about displaying this is that I thought this would be a good starting point for our discussion today. If you look at the people working with science, engineering, I think we all are trying to kind of decipher the secrets of the nature, maybe as a scientist, and as engineers, we are trying to work out how do we make the best use of the learned secrets of nature. So that is why I consider this as an absolute privilege for me to have getting an opportunity to talk to an audience like this. Before going forward, I would like you to get your input into this forum through this Menti tool. Please go to menti.com and use this code 23894149. And there I have a question for you. And this question is asked for us to understand about each other a little bit better. So, and I'll be using these responses in my talk today. And this is my question. So I would like you to share the most beautiful scenery or memory you cherish in your life. Sorry, I think, yeah, you have to use this code that is shown on the screen, menti.com 77531102. I'll wait for around 5 minutes for the responses to come. So rather than asking where are you from, what are you doing as a profession, I thought a better question for me to ask to know each other would be, tell us the most beautiful scenery or memory you cherish in your life. The most beautiful memory you cherish in your life. And you can do that by going to your browser, type in menti.com and use this code. My connection. So thank you for those responses. The next question I have is, as we can see, looks like we all are sharing some of the memories to be best memories. We have common best memories. And the next question I have is, what do you spend most of your time at work on? So when you are at work, for example, today, what do you spend most of your time? I hope the question is clear. So is it about written communication, like writing reports, writing emails? And sorry about the typo here. And or are you physically, a lot of your time is time is spent for physically engaging with people, or you are working with designing, or are you coding a lot? Basically, I'm asking as an academic, what do engineers and people in the audience are spending their most of the time on? Yeah. Okay. It looks like the written communication kind of, okay, no. Yeah. Yeah, so either it looks like actually most of our time as professionals are spent for maybe on written communication, like writing reports or writing or writing emails, writing reports, or etc. Or it is spent a lot with physically engaging with people, meeting people, talking to them, convincing them, maybe mainly convincing them or teaching them or things like that. And also our lives as engineers typically are spent on a lot of time coding and also design. So therefore, around that, session will be done by myself and Dr. Shamni. And in fact, I think it's around 1 o'clock in the morning for him. So I must thank him for joining this session. And I will take the first half of the session and he will take the latter half of the session. And a little bit about myself. I'm a graduate of Faculty of Engineering, University of Peradeniya, and I completed my PhD at the University of Melbourne, Australia. In my PhD, I studied around microbiology and machine learning. And I focused a lot in machine learning in my PhD. And now coming back to Peradeniya, after coming back to Peradeniya, my research interest and also my teaching interest are around machine learning, explainability, which are coming under the topic of artificial intelligence. And I guess because of that, I have been exposed a lot into this concept of generative AI. But in terms of the real hands-on experience around generative AI tools, I think Shamini is in the forefront, developing these generative AI tools, whereas I am in the other end using these generative AI tools, and I'm looking at as an educator how I can use that to make my teaching effective and how can our students use these tools to make their work effective, etc. And I'm also a facilitator for this group at University of Peradeniya called Artificial Intelligence for Academics, where we discuss about how can we really use these new innovations in AI to facilitate our teaching and learning process. I think that is the very reason that I was contacted by Dushyant to deliver this talk today. So this is the outline I have chosen for the talk today. I will give an introduction to generative artificial intelligence or generative AI. And rather than telling how to make best use of out of it, because based on the audience we have here, and given that you will be already using these generative AI tools, I will be focusing a lot on what it is not. So I will give an introduction to generative AI. At the same time, I would like to emphasize on what it is not. So because if we have a good understanding about what it cannot do and can do, I think we can best use out of them. And both of us will do demonstration of some of the tools, and I will demonstrate on generative AI tool for images, whereas Shamni will demonstrate generative AI tool for text, ChatGPT. And we hope to wrap up with the discussion among each other. What is the way forward, how we can, what we can do through these tools and to learn from each other mainly. I hope it sounds good. So I will start off by giving a brief intro into this whole concept of artificial intelligence, machine learning, and deep learning. If you're already familiar with this topic, bear with me. But if you are not, I hope you will find this useful. So intelligence is not something that is new. It's not a topic that is new for us. So we have been talking about intelligence since before Christ, maybe. I mean, Plato has been talking about it. And we have been always curious about the question, what does it mean by intelligence? And can we make machines that can mimic the intelligence or the behavioral patterns of human or any other living entity? So this is the exact question that we are trying to answer in artificial intelligence. Can we machines that can mimic the intelligence or the behavioral pattern of humans or any other living entity? So we know that it's not only humans that are intelligent. So I think we all agree. It's not only humans that are intelligent. There are other entities who are intelligent. So in artificial intelligence, our goal is try to make machines that can behave or think like in these living entities who are intelligent. And this is a very broad area, and we have been talking about this for a long period of time. And we started talking about this topic very intensively, maybe from since 1950s. In 1950s, I hope most of you might have heard about Alan Turing, the very famous scientist behind the imitation game, or the film is about him. And so Alan Turing posed this question: can machines think? And then he also posed the question: if machines can think, how do we identify? How do we answer yes or no to that question? So world has been talking a lot about this famous Turing problem. And also in around 1950s, we coined the term called artificial intelligence, referring to the machines who can think and act like humans. And let's fast forward a bit. Now, we were trying different ways to achieve this artificial intelligence. And one way we try to achieve artificial intelligence is through machine learning. So the idea of machine learning is that it's a field of study that gives computers the ability to learn without being explicitly programmed. I think that's a very straightforward definition for what machine learning is. So in this diagram, as you can see, in our typical scenario, in classical programming or in classical way of problem solving, what we try to usually do is we would have some already identified rules, and we will input the data, or we use both those rules and data to deduct answers, to come up with answers. So this is what we do in classical programming or classical problem solving. Maybe if you pose an optimization problem, or if you are developing a software with logical constructs, flow constructs, this is what we are doing. We already have a bunch of rules defined, and we are sending a bunch of data. And by applying that data, giving that data into those rules, we are trying to get answers. Whereas, interestingly, in machine learning, what we are trying to do is we assume that we don't really know the rules that are governing the underlying behavior of a particular system. For example, I want to predict weather for tomorrow. And one way to solve that would be try to derive what are the rules, what are the variables that is affecting the weather tomorrow. Another approach would be gather large amount of data or gather data around that, and also gather answers around how the weather has been, and use machine learning to derive the rules. Now, if I have derived the rules, the advantage of that would be, now I can use that rules to predict the weather for future data, for future time, for a future date. So this is the basic idea around machine learning, and we talk about different approaches to do machine learning. We mainly three now. One is supervised learning, the other is unsupervised learning, the other is the semi-supervised learning. So behind generative AI is self-supervised learning. So I hope the idea of machine learning is clear, what we are trying to do in machine learning. And now, again, there are different ways we can try to do that, because now we have the data, we have the answers, and we want to derive the rules. The data can be text, data can be images, data can be just numbers, and answers can be text, answers can be images, answers can be just numbers, or answers can be classes, categories. And based on the sort of data we are working with, we have different machine learning models that we can work with. And one such set of models are the deep learning models. So deep learning, again, is this specific branch of machine learning that specifically focuses on machine learning with deep neural networks. So the idea of neural networks is, it's also again very interesting. Immediately when you talk about intelligence, I think immediately there's an organ that comes into our mind, that is our human brain. Now, one way one could think is, if I want to mimic intelligence, let me mimic my brain, the human brain. So this is exactly what we were trying to do through neural network models. And we have been trying to do this since around 1950s. But around 2 decades or so before, we saw a large increase in the amount of data, as well as we saw a large as well as we see an increase of the computing power, especially by the use of graphical processing units, GPUs. The computing we could do large computations in more efficiently, and with that, the studies or the field of neural networks expanded a lot. So this deep learning particularly focuses on performing machine learning inspired by our brain's own network of neurons, or what we call as neural networks. Okay, now coming to generative artificial intelligence. So as I said, there are different approaches we can take in machine learning. One is we can do supervised learning, where we know the idea of supervised learning is, it's like, now you are seeing myself, and probably now you will identify me as Damayanti. And maybe in other places, you will see different images of myself with a group of people, and maybe wearing something else, some with a different dress code at a different function. But again, you would probably be able to identify me, which is basically a classification task. Now there, what happens is, what we do is we have certain data, and we also have labels for those data. Given an image, you know that image corresponds to Damayanti, or that image corresponds to some person. And so that learning process is governed by the label. Such a process we call as supervised learning. And for a long period of time, we were focusing around improving the supervised learning process. This is why, in fact, in this diagram, I am having a very simplistic view of machine learning, where I am saying that I am giving the data, I am giving the answers. So these answers will act as the supervisor for my learning process. Basically, I am actually representing here the supervised learning process. But if you think about a baby, if you have babies at your home. Now, we don't really tell babies, we don't give data to babies, and at the same time, we always label them. We always give answers to the baby. But rather, this is how a baby would learn if you have observed. What you can do is just put the baby on a mat in the house, and then if he or she is looking at the door and looking at the people who are coming into the house and how they are interacting, you don't really have to tell to a baby, okay, if someone comes, you have to say hi. If someone goes, you have to say bye. Or when someone is coming to the house, we usually smile. You don't really have to teach them. You are not really supervising. Rather, what you're doing is, now what baby is doing is, he or she is sitting on this mat, looking at the door and just gathering data, gathering large amount of data, and it itself is learning how to react to different situations. So this is the kind of scenario that we see in self-supervised learning, where just think that we don't even have answers. Instead of answers, I am giving only the data to the system, and I'm asking it to learn the patterns underneath and also give me the rules. And this is where we are in terms of in deep learning, which we call as generative artificial intelligence. ML is a branch of AI, and deep learning is a branch of ML. And generative adversary networks, which are behind generative AI tools, are actually a branch of deep learning. Deep learning. So you can consider these generative adversary networks or large language models as neural networks, neural networks or deep neural networks, which are performing self-supervised learning. And the idea of generative AI is now we can use this model. This is the key. Whereas previously we were just looking at giving the data and giving the answers, trying to derive the rules so that we can apply it for future values. But now it's a different perspective. We are using these neural networks to generate new and original content from existing data. So that is the key. We are trying to generate new and original content from existing data, if that makes sense. So how does the generative AI tool works? So the typical setup of a generative AI tool would be, I give a certain input, which we usually term as the prompt. I will input and prompt to this generative AI tool, and I will have a generated response. For example, for ChatGPT, you can give a sentence and say, or you can ask a question as the prompt. Interestingly, you can just try giving your name, I'm just picking up, who is Naveen Amrasinghe? You can just ask from ChatGPT and see what is the answer it gives. I just selected a participant. So that would be the prompt, the question that I'm asking that tool. And then I will have a generated response from the generative AI tool. This prompt can be, as I said, the data, the prompt can be a text input, the prompt can be an image input. And then it can generate responses in terms of a text, or it can generate responses in terms of an image, or it can generate responses in terms of sound, a song, etc. And how did we make it out? How did we work it out? I think this is the most interesting part for us all. How are they doing it? So as I said, here we are using neural networks, specifically two types of neural networks, which we call as, one is the transformers, which is behind GPT. The other is the generative adversarial networks, which is behind tools like DALI 2. We give the input prompt to something like GPT-3. And if I ask the question like, recite the first law of robotics, it will send this input prompt through this model and give me an output. How does it do that? This is how we do that. So now we have some idea about how does machine learning model works or a neural network works. How it works is it take input data and the network will have certain number of parameters which can be used to predict value for a future input data. So the process training refers to figuring out these parameter values of a neural network. And in the training process, what we are actually doing is, in this training process of large language models, what we are doing is we are taking large number of text data or image data and sending it through this GPT model until it can basically autocomplete these sentences with a high accuracy, with an accuracy that I desire. I think we all are familiar with in our mobile, you are typing out an SMS or an email message, there will be autocomplete. In a way, these large language models are doing autocomplete, but the very prominent element is that they are doing it using neural networks, and to do that, they have been trained on large amount of text data. They have been trained on large amount of image data. So what does that mean is, it's, for example, to similar, I'm simplifying things a lot. I'm simplifying things a lot. It's like, you are reading all the books that are written by Shakespeare. You read all the books that were written by Shakespeare, and after doing so, you are now able to identify or extract a representation of work of Shakespeare. Like, okay, these are the sort of wordings he's using. Those are the patterns of dialogues he's using in his work. These are the sort of plot he would have in his plots. This is just a hypothetical example, but it's similar. And then if someone asked you to write, can you write me a plot similar to Shakespeare? Now, what you can do is, if you have already extracted that patterns, what you can do is, you can probably come up with a decent plot that would look like written by Shakespeare. This is exactly what is happening in large language models. And the very element that made them powerful is that it's around language. Language is what we use to communicate with people. And if you look at the world around us, a lot of it is around language. If you search through the web, there are a lot of text data. So what they did was, they basically, what we are doing here is, we can now gather a corpus, gather data from the web, mainly from the web and from other sources. We can gather large amount of data generated by humans around different sources, creative writings, news articles, and maybe the factual reports, etc., etc. And here lies a large neural network with large number of parameters, billions of parameters, and powered with large amount of computing power, large amount of GPUs. We all know OpenAI is behind GPT-3, so they have access to this large amount of computing power. And they developed this tool that, given a sentence or given a phrase, now it can very, very plausibly predict what should be the rest of that sentence. So I feed large amount of data to my neural network, and I give usually what is the output to those set of inputs. And now my neural network is trained so that if I input a new sentence, it can very well plausibly complete that sentence. This is what we were trying to do with large language models, and this is what OpenAI was trying to do. And it's very interestingly, and it changed the way we worked. Now it's a lot of people, I think there is a lot of focus in, a lot of people are researching around these large language models, developing their own set of tools. But this is fundamentally, this is what is happening inside. And so just to explain this figure, what we are saying here is, this is what happened in training a large language model. So I have the input like a robot must, and the correct output, the label is obey. And I am asking it to train to predict that. And how do I do that is, maybe in the first iteration, when it is training, it will not give the output as obey. It will give some other word as here, something exterminate, but that is wrong. So in the training process, what I will tell is, no, it's wrong. We retrain up until it can correctly predict the value, the next word as obey. And with something like that, this is what we are seeing. Once you have such a model trained, this is untrained GPT-3 with large number of parameters, but after pre-training, I have GPT-3 now, which is released to the client, which is released to the users, which is released to me, which is released to you. What I can do is give new input, and it can generate answers to my prompt. And now, but before I go forward, is there anything that I should explain? If that makes sense, can you just give me a thumbs up? If that makes sense.
Can you hear me?
Yes, I can hear. Yeah.
You mentioned that the machine learning data and answer, the result will be recall rules. Shall we call it as a prediction or forecasting? We do the data and answer. Shall we get the forecasting, but we want to do all the prediction? The result?
Not really, because output of the model would be, it is just predicting, it's giving the set of rules. But we can use it for prediction. We can use it for forecasting. If that makes sense. So, but I think it will be a little bit erroneous if we project it that way, because this is the learning process actually. At the end of the learning process, we might have a bunch of rules, and or maybe in neural networks, we call them as weights, or some sort of a model. But then we will use that model for forecasting, for prediction.
Can we call it as what we expecting? Can we get from that? Expecting.
The expectation would be probably the answers, isn't it?
The one is the next. Shall I ask another question? That we have to do the training. That how we can find that training information we are giving to the system.
This training process actually differs from the different machine learning models that we are using. As I said, we can do supervised learning, unsupervised learning, self-supervised learning. So the training process will differ based on the approach that we are taking. I will stop there and I'll move forward. Right. So as I said, so the transformers of what is behind GPT-3 is one sort of a generative AI technique. And what we see in something like image generation is again similar, but they are using another generative AI technique called generative adversarial networks. So what, for example, what we are trying to do is feed it large amount of different versions of courses and with captions. And then if I give a prompt again, which is similar to the caption of the image, now it can generate a new image. With what we have seen so far around machine learning, deep learning, and these generative AI tools, as we can see, as I mentioned, we can, there are, the prompt can be text images, the output can be text or images. And now we see a large number of generative AI tools that are developed for different purposes. To generate images, to generate text, to generate music, etc. And even at Peradeniya also, this came into a lot of, this became trending around, I think mainly a year before. Even last year, we were looking at, because we are at the university and we are looking at education, we looked at how we can use these large language models to develop a custom, cost-effective, intelligent tutor. For example, it can be a personalized tutor for the students. And there are a lot of such work being done. And if you look at even, in our current iteration of our undergraduate research projects, there are a bunch of projects that they are focusing on leveraging large language models for different solutions. Now, I think with that introduction, if you try to apply it to yourself, or if I try to apply myself, now you might be seeing different applications that these generative AI tools have. Depending on the engineering discipline, depending on what sort of work you do in your daily lives. So that is why, and I think, in fact, I was looking at one of the responses. There was a question asked. I'm working with coconut plucking workers. So how can I improve that process? That's a very interesting question, and I think it's a good question to discuss as well. How we can really leverage these tools for the betterment of the people around us. But I think at the same time, there is no perfect answer, correct or wrong answer for that, because I think we are working on very, very specific disciplines, doing specific things. Therefore, I thought in this talk, both of us will focus on giving a good idea about how this tool works. And with that, I think if you think about how these tools work, there are three key conclusions we can make. One is these tools are limited to the training data it has seen. So these tools, they are large neural networks, they are deep neural networks, and they are trained on a certain amount of data. Therefore, they will be limited to the training data they have seen. And also, because of the same reason, it can be biased to the data it has seen. And there is also an implication of ethics when we are using these tools. I would like to spend a little bit more time around that to discuss actually what generative AI tools are not. If you are using generative AI tools and get some idea about how this works, I think now you can think how I can apply these tools in my day-to-day lives. You can apply them to, generate as a companion, for example, or Shamne will demonstrate how they can be used with ChatGPT. I'll give some examples as well. But before going there, I would like to explain or discuss what it is not, what generative AI cannot be used to. Of course, we can use something like ChatGPT to conceptualize, or maybe improve an idea, but that would not be a really good tool to be used to generate new ideas or solution to real challenges, because that challenge would be quite specific. Would be quite specific to the people we are dealing with, to the community we are working with. And also, I would also like to highlight the difference between search and a generative AI tool. So I think we are all familiar with when we have a problem, we do a Google search. What Google search does is actually it's searching through this large amount of, it's a large database. It's searching through this database of different sources. And it's not generating an answer. It's picking an answer from that data and it's showing us. This is what happens in searching. But when we are using generative AI, it's not really doing a search. It's generating answers. Now, because it is limited to the training data it has seen, it's possible that it's not 100% accurate. For example, if you're a civil engineer, if you're trying to write a report and if you ask GPT, it's possible maybe sometimes the ranges, the numbers it is talking about is not really, it doesn't really match with the setup you are working with. I mean, the standards, Sri Lanka would have different set of standards, the USA would have different set of standards, and probably GPT has seen a lot of data from the USA. So now what will happen is in its answer, it will have more content relevant to the USA, not really to Sri Lanka. So therefore, we have to be careful. So so it's very, very important that we do fact check when we are using these generative AI tools. Fact check by ourselves how much correct the answer is. And also, we have to be careful. As I said, these models are trained on already existing data, human-generated data. And now what we are doing is, we are kind of replacing that data with this generative AI generated data. For example, let's say we all start writing emails using generative AI tools. Now, what will happen is in the future, all our emails will have a different form compared to how our emails look like today. And then the next models will be trained on that input. And so, therefore, we have to be careful on the sort of prompts that we are giving into these tools. Like as it is said, don't ask it to solve problems relevant to your family matters, or maybe related to your work. Very sensitive questions, because that it is possible that get added up into training data And the next iteration, we will have the bogus results coming out of as responses. And so there can be hallucinations, these made up answers. We have to be careful on that. And the other very important aspect is the copyrights. So as professionals, I think we have to think very seriously about the copyrights, intellectual property rights in using these tools. But before working on that, let's try to get some hands-on around this. Can I quickly ask, how many of you are not familiar with Bing Image Creator? How many of you are not familiar? Can you please give a raise hand? Yeah, now, whether you're familiar or not, I would like to quickly do this exercise with everyone. So what I would like to do is go to www.bing.com or go to bing.com/create. And I would like you to create an image. I would like you to create an image. And so And to create that image, I would like you to use one of these responses. Let's try to give ourselves a break and try to visualize. We have a bunch of responses as the most beautiful memory of their lives. Let us use this as a prompt to that tool. And I would like you to generate an image with that prompt and kindly add that into this slide deck. So I have given edit access to everyone. You can duplicate the slide, add your creation here, and add your preferred name. I would really love to see some of the creations. So again, I will share this link. I will share this link. Now you are able to edit this present slide deck, and we will take some of the prompts out of these responses, and I would like you to go to Image Creator in Bing. Please use the Edge browser for that. What I'm asking to do is going to the Bing browser, sorry, the Edge browser, and we can type Bing/create, or you can just search for Bing Image Creator. And it will lead you to here, this application. And let's try to recreate some of those memories. You can pick any of those memories and paste some of those creations into that slide deck. Am I making sense? And while doing so, please ask me if you have any questions. So this is the image creator from Microsoft Bing, which is leveraging the daily tool from OpenAI. What it does is take a prompt from this input. You can give any prompt and click create, and it will generate images. If you want to get some ideas, there are some example ideas. And these are my previous creations I can leave. If you have any questions, but please feel free to ask. When we are inputting a prompt, giving a text input as the prompt, what we have to remember is this is actually trying to generate images. So the model does not. I see some answers. So what I was suggesting is, in fact, to use some of these memories. For example, I will take this. Do you have any questions? Anyone having trouble going to image creator in Bing? I will pick, I think the most beautiful memory I would say personally for me is the moment I saw my little daughter. So now what I would do is I will go to Microsoft Edge Image Creator. Now the thing is that memory is as the moment I saw my daughter. But because this is a generative AI tool, the tool have no idea what does that mean, the moment I saw my daughter. All it knows is, given a prompt, generate the corresponding image. So therefore, it's a must that I be as explicit as possible. For example, I will have to describe that memory a little bit more. So rather what I would say is, I would say smiling baby girl, newborn, and sparkling eyes. I don't know, sparkling eyes. What else? I can also give the sort of whether it should be what sort of an image it should be. It should be like classical, or it should be like a painting. It should be like what sort of an image it should be. So I'll just try some. Actually, one tip for using this is to use as much as adjectives as possible to explain what you want to express. I'll just, for the time being, I'll use this and I click create. Now there is a comment in chat. Now this technique is there in WhatsApp new update. Yeah, that's great. So I think yeah. So these are the images that it has been given. It is generating, and lovely, isn't it? So so we can, as we can see, I think immediately you can see how this can be a very good tool to express ourselves, or also to validate our ideas. For example, today I was talking to someone from our mathematics department, Dr. Rajit, in fact, he's here. And I was just thinking how a mathematician, because engineers are also using a lot of mathematics, how we can use this to, how engineers can use this tool to visualize things. And I think an example would be, I can ask something like, I was trying to generate something like, I don't remember the exact one. Fibonacci. We all know Fibonacci and 50 flower. I'll just create. So this is what it generates. So I know mathematicians are working a lot with nature and patterns of nature. So now what I can do is I can try to, use that to visualize maybe some of these mathematical concepts. And also, this can also be used maybe, I see a lot of answers coming up in the chat. This can also be used by a civil engineer, for example, to if this cannot be a substitute for real design tool, but maybe if you want to visualize or conceptualize how a building look like, we can say modern. Can you give me a prompt? Civil engineers who are working with these building structures and all, modern green building, lotus shape. Building shape, high rise. Yeah, so sometimes these can be bizarre. Maybe they are not really as you expect, but the thing is you can keep improving them. So the limit is the imagination that we have, in fact. So there are different ways. I see some answers, some generations coming up, I think. Yeah, so you can, there was some memories around sunset. I think they are trying to, that's a very beautiful visualization of that memory. So that's a very, I think you all agree how this can be a powerful tool in terms of generating visualization, so conceptualizing things. So there are different techniques we can use to improve this prompt. As engineers, I don't think it will be a hard task for us to really work out these things. But again, I would like to emphasize and wrap up my session around these generative AI tools for images, noting about this. So moving forward, I think the most important thing is to be aware how generative AI tools works, as well as what are its limitations. What are its limitations? And I think we had to have a very good understanding and a discussion around the importance of ethics and the importance of the copyrights of these generated text, generated images, generated content. And the other thing is, I think we should be having a lot of leaders in this forum, people who are leading teams and people who are designing things and also, leading innovations, leading new projects, and now guiding people, teaching, educators. So then again, we have to have a discussion around the governance of these tools. What are the measures we have to take to ensure that we take fair and proper use of these tools. I will wind up with this. This is my, as someone who is working related to artificial intelligence, I think personally, this is the key. If you look at now, generative AI, it has come and it's going to stay. And as humans, we will have to learn how to cope up with these tools. Then to learn how to cope up with these tools, now we have to think what separates us from these artificial tools as humans. I think what separates us as humans from these tools is the fact that the fact of connection. As humans, we know how to connect with people, which generative AI has not yet worked out. And yeah, so, and the other thing is, I must mention is the intimacy. I am doing this session to you. I think different people in this audience will be perceiving this in different manner. And I'm making an intimate relationship with you when I'm talking. And just try to compare it with having the same conversation with GPT-3, with ChatGPT. Would you have had the same effect if ChatGPT was doing this session? I sincerely hope not, and I stand out as a human. Then we have to think, okay, what is it that separate us out as humans? I think it's mainly about the connection we have with each other, as well as the connection we have with the nature, which AI is yet to conquer, yet to identify, yet to understand. So I think it's very important that we understand that fact, which again will bring us to the importance of ethics and governance around AI tools, so that we can cope well with these tools. But before going into the discussion, I will wrap up my session with that, and I will hand this over to Shamni to continue. Hi, Gayan, I hope you are there.
Yeah.
Okay.
It says I can't. Can you please make me a co-host? Because I can't start the video. Yeah. I guess I might need to become a co-host to share my video. Hello?
I am not a host, but I could share my screen and also video.
No, I guess you are a co-host. I can see it because in the chat, yeah.
Oh, maybe then I can make you.
Yeah, you should be able to make me a co-host.
No. Dushyant, maybe we'll have to do that.
Yeah, Dushyant, are you there? Or maybe. Okay, now it's good.
Okay, great.
Yeah. Give me a second. I need to check. Yeah. Hi all. So yeah, thanks a lot for that amazing introduction to Gen AI. I'll start the session by introducing myself. So I also finished my undergrad at the University of Peradeniya around 2016. So my major was in electrical and electronic engineering. Then I completed my master's from University of Auckland, New Zealand, where I worked on deep reinforcement learning, which is like a subfield related to artificial intelligence. And then I completed my PhD also from the same university, the University of Auckland, New Zealand, where I worked on domain adaptation of foundation models, pretty much like these language models. And actually, yeah, that's where everything started. So right now I'm in the industry where my main work is about kind of adaptation of these sort of language models. Yeah, that's like pretty much about me. So yeah, moving on. So I will kind of show you some examples how I use generative AI tools every day. I pretty much use like every day, almost 90% of my day-to-day tasks are being completed with the help of Gen AI tools. And also, like I still do coding and all as well because I work in industry, also a lot of planning, and I use both. I use many tools for all these tasks, like when it comes to planning, when it comes to writing, as well as for coding. Or I still needs to read papers, get things out of them, and build different arguments or different workflows from these research papers and all. So yeah, I pretty much use them every day. So what I will do is I'll kind of show you people like how I use this, and you can get some insights. But yeah, just feel free to ask any questions. I know we also have a discussion time, but if you feel like if you have anything related to tools or this theory or something, just feel free to ask. And I'm gonna share my screen first up. Yep, my can you see my screen? Should
Yes.
be okay,
Yeah.
right?
Yeah.
Okay. So uh, yeah, I'm using ChatGPT. Actually, this is GPT-4. So this is like the paid version, pro plan. And there are heaps of different services you can use, but like I mainly use these three, actually these two, but this is like a fun thing. So I'll start with this. So this is similar. This is something similar to what Dr. Damayanti already showed you. It's like text. It's like a text to image tool, but this is direct from OpenAI. We call it DALL-E. It's a kind of a it's a different algorithm, but pretty much there are very similar theories with language models. We call them like stable diffusion models. But yeah, just the idea is like you can type anything here, say like generate a nice human hybrid with uh, rabbit genes, something like that. So say like I need some kind of a hybrid phase where you kind of can see different properties of both human and rabbit. Let's like it was just a random thought that came into my mind. Yeah, so you get something like that. It's pretty fast, and that's so this is like you can do a lot of fun stuff. And if you go to ChatGPT, Explore GPT, and there are heaps of different services where this is like this not only from OpenAI. You kind of can build applications on top of their APIs, and it's like it's like built-in applications for your iOS phone or Android. It's not only Apple makes them, right? Like other developers and companies around the world would just uh, come up with different ideas, and then they can also provide different solutions. It's kind of similar to that. Platform is OpenAI, but some of like for example ChatGPT, DALL-E, data analysts, these three are originally from ChatGPT. Like these are like services, but there are also other services. Honestly, I haven't done much around this, but there are a lot of things like for productivity, for research and all. But I'm not going to spend a lot of time on different things. But you always can kind of look into it. So this is around $20 like USD per month. I know it will be a bit expensive in Sri Lankan terms, but I mean, not that it's not that expensive compared to some other apps that in the market, honestly. So yeah, moving back like to ChatGPT. So I'm going to show you like how I use this tool every day. So first thing is like I usually use this one GPT-4. Although I pay for the service, there's a limit like 40 messages per every 3 hours. So I'm not going to use that solution now. This is more, I would say, more novel, and this is also more accurate because it's like a modified version of the original ChatGPT that we saw in not last December, like 2022 December. But yeah, right now for our purpose, I'm using this, but I usually work on this, but I just need to keep my message limit for today. Yeah, that's all. And so first thing is like something I do is say like this is something I always do. So good, like I told you, my job requires me to read papers and get some ideas, and then go into implementations because I work in an R&D team. So yeah, we get to read a lot of papers still. It's never ending thing, you know. So good old day, like we used to read this from the scratch and trying to understand everything by itself. But you know, like time is like the key nowadays. And if there's a better way for me to kind of go through this paper and understand this paper, this it would be amazing. So this is something I always do. So what I can do is I can actually yeah. Mm, so yeah. So I can only upload PDFs into the service if I only use ChatGPT 4, but it's fine. I'm gonna anyway use that for now because this is something I actually want to go through today. So what I do is I can upload that PDF which I have already downloaded before this paper. Then I can ask like um, mm, uh, mm, summarize the main findings of the above paper for a person with a PhD in NLP. So you know, like these models, they are like they can understand the semantics. That means they can understand different variants of our language. So the idea is like if you just say like summarize the main findings, it might go a bit too shallow, I would say, or like be too simple. That would take a lot of like that would take a lot of time for me to maybe read unwanted stuff and all. But with this thing like person with a PhD in NLP, then it kind of can understand, or like I don't need to go super shallow, you know. So yeah, just like so here if you can even say for a 5-year-old or something as well, and it will kind of generate things accordingly. But here, what another, so now it says this paper presents a new method for rebasing of neural network models using implicit synchrone differentiation. So I know like it's like gibberish in the first go. So I can always have a conversation with it. So I can say, can you come up with some points, and then explain the implicit synchron differentiation. I also need the main findings especially related to model merging. So yeah, just I asked about like this exact technique that they use to kind of do some things, but just don't think why I'm using this. It is like related to one of my papers, so I kind of can get a good idea, you know, like rather than directly jumping into the paper, I kind of can get a good idea. Oh, this is what it does. So like 2-3 years ago, the thing is like I had to kind of go through this paper all by myself. Maybe uh, it might, you know, it might just it could waste my time as well sometimes, because like when it comes to certain research papers and all, we just need to get the idea like what is happening with it, and or what are the main contributions, and more like key terms, like for example this part that it actually picked this part, like this is something, if I don't understand this exact thing, now I just don't need to like go through the paper first up, like, or what I can do is I can kind of do some sort of a search about this exact technology, or sorry, exact mathematical concept, and then I kind of can go into the paper, because I know if I just read this paper without knowing this part, it would be pretty much gibberish to me. So yeah, that's pretty much it. And also I kind of can get main findings in the point form. So it's like it's efficient merging, maintaining the functionality, permutation, symmetry, merging. So another important thing is like uh, what I wanted to highlight by taking this example is, so it's not just like parroting, or it's not just like summarizing some text, like it uh, it does it does have some sort of an understanding, like deep mathematical understanding. And this is my personal opinion, I believe these models are pretty much good at mathematics, better than us. And it's just like a matter of time until they surpass our mathematical brains, you know, like for example, things like see, like this model just picked something called permutation, symmetry, and merging. So I can type explain permutation, symmetry in merging, or maybe just permutation symmetry for an undergrad student in engineering. So yeah, this is like a core concept, like permutation symmetry neural networks refers to the idea that you can rearrange the neural network's layers without changing its overall behavior or the output. Show it with some mathematical concepts and come up with a simple Python code. Yeah, so it can even like this code is actually correct. Like I know, so my point is, say like when you ask about the mathematics and all, like this model kind of can explain that concept. So this is the concept in pure word form, but then this model also can kind of explain the concept in mathematics, which is like pretty cool, you know. Like, so my point is, it is not just like copy pasting stuff from there. It just like it kind of can, there's some sort of an understanding, we call it like contextual relevance. And then yes, like there's this code as well. So actually if you want to code, there's this another thing called data analysis. Pretty much it's like text to coding, but when you are using GPT-4, GPT-4 can automatically connect this tool, like data analyst tool, when it is needed. So yeah, this is like pretty much one example I'm using. Then obviously we all know I use this for everyday messages, emails, and all. And I also have to mention, like, when most of PhDs join industry, it is like writing is a skill that we always used to sell, like, because it's easier for us to write. I mean, because we used to write a lot, right? Like in our postgrad days, but not anymore, like now writing is not even a skill, and even almost all our research conferences and everything, they accept AI written, or like these kind of writing tools. So we already, like, now it's been like 2 years after this technology, maybe 1.5 years. But so even for today, like you can see, there are a lot of rules and regulations that where you can that actually they are not there to demotivate you to use Gen AI tool, but more of like they highlight the fact that you should coexist with AI tools, writing, doing your coding and all, and you can always ask any question regarding how I think about these coming up changes, how I think about like different different like how I think about this paradigm shift, if I say it correctly, because I seriously believe most of the things that we do will get automated, or more of like we will get pushed to use these kind of tools. Like it's in a way it's a good thing. Like even the coding is like, my personal opinion is a software engineering job, which is like I do a lot of coding, but it is not anymore a lucrative job, in the world, because we already, because most of because coding is all about, you can see, working with some sort of a structure, and these models are really good at understanding the structure. So my point is, it's not just like entirely everything will get automated, but there will be a point like we will get pushed to use these tools to make our work much more efficient. That's the end goal. You need to do things pretty quickly, also in an accurate way. Um, so if I want to show you one more thing, like I'm also using something called GitHub Copilot. So the idea is kind of simple. Where am I going to? There's my Zoom. Okay, first I need to stop sharing. Just a quick thing. I know it's been a bit late for you all as well. Yeah, I guess you can see my screen, right? The coding one. So this is my VS Code. Like, this is the idea I use, but I also have this solution called GitHub Copilot. So this is a pretty cool thing, like, so in coding, one thing is writing documentations and test functions. Right now, I mean, for like last 12 months or something, I pretty much, not 12 months, maybe 8, 9 months, I pretty much use this tool, because this is like pretty cool, like this can help me a lot. Like, for example, let's say this is a class and I just want to come up with I just want to come up with a description for this class. I just want to do is like generate docs. So it will show, like, see the docs being generated, but I just don't want to change this code. And then there's a function. What I can do is actually I do this and I right click and the Copilot is there, and I can just type explain this. It says it seems like you're dealing with the number of printing errors. Yeah, I guess that's just like that explains the linting errors, but I can actually explain the main functionality of the following. So yeah, previously it was like it was too big, I would say, like, but my point is like I kind of can always explore what is happening with the code, and this can also autocomplete stuff if I type like, so yeah, my point is like so this is a specific integration of Gen AI for coding, and yeah, this is something I use every day, and you can also search about it, like it's called GitHub Copilot, especially if there are students and all, you can use this for free, I guess. You don't have to pay, otherwise it's like $10 per month, or not, or 100 per year, something like that. But it is also pretty chill, and yeah, this is the tool, GitHub Copilot, and yeah, and like just try to. My point is try to use these tools in your day-to-day work. It will definitely help you in future. Okay, I think that's. I just don't want to take your time a lot. I guess like that's pretty much it from my side. And yeah, I'm happy to answer any question or anything. Yeah, like let's see.
Hello, Doctor. Now I'm from the industry. Now we are using Cloudera data platform, so which acquires the auto networks earlier, and then it became a monopoly product. So can we, I mean, gradually or in any case, can we replace Cloudera platform on this chat OpenAI? Like, do they have virtual data platform and all that to use the machine learning AI and all that?
Could you please explain, like Cloudera is something like AWS? Is it something like a database, or
it's a Hadoop cluster where we use store the data and analyze the data in terms of
okay.
Yeah.
So something like Databricks or Snowflakes, right?
Yeah. We use Kafka for streaming and all that.
Okay, got it. I don't think like that part is not there yet in these kind of solutions, and I also don't think they would come up with such solutions, because the big thing would be the privacy, right? And we also need to always understand like there's this training element to all these solutions. Like they need to keep training their models, right? And then the big thing would be people would question about privacy. What will happen to my data? Will they keep that? Will they use that data or something? I mean, although they can say like we are not going to use it, but still I don't think they would go up to that extent, because like imagine then it's like OpenAI needs to come up with their Hadoop clusters, come up with their S3 buckets or something, all this stuff, right? Like it would be a mission for me, like practically speaking. So how I think this would go is like we don't know. They would come up with this stuff because it's already $1 billion company. But this is like my take on this is you could still keep your data in like things like these Hadoop clusters, cluster versions or cluster. I don't know like how to say it's like a service, right? So I usually work with Databricks and Snowflakes and AWS. So you can always use these tools, right? Like you can always call GPT-4 or like OpenAI APIs from your applications, and yeah. But as far as I know, no, like I as far as I know, OpenAI doesn't do that hosting part yet. But there are some things like, for example, they can create embeddings for your data and all. Like you guys might have heard of these vector databases. It's like a cool concept, especially to search and all. But still, not in that Hadoop level or distribute like PySpark level, or more like we call it like they don't have HDFS clusters as far as I know. Yeah.
Thank you. Thank you.
Okay.
But what I heard was they are protecting the data privacy and they do have a virtual private data center or something like that. But I just started searching on it. Let's see how it goes.
Yeah, exactly. They have a data privacy. I'm not saying they don't have it. Obviously, like end of the day, we keep all our data in AWS, right? Now there's like remember like 10 years ago we used to have our own data centers, like kind of like our own servers. Now no one is doing that. So obviously we can use these cloud solutions. Actually, that's why I said OpenAI surely can do it. It's like just bread and butter with the amount of their money, you know. But I don't know they would go and do that because like at this moment you don't need to you don't need to get these unwanted attractions. That's what I thought, like, because always there are other cloud services, right? Azure is there and all. Yeah.
Thank you, Doctor.
Thank- Yeah, there's a question. I don't know who wants to take it. Damayanti, you also can answer that if you want.
Yeah, but
So yeah,
what are the
the
best
question is,
sources?
yeah,
Yeah, you can
go
answer
ahead.
then. Yeah, you can go ahead. Yeah.
What are the best sources we can learn how these tools we can learn how these tools are built? Can we try? Yes, of course. So the question is like, are there any resources related to learning the underlying concepts of these transform models and all? And also, can we build them from scratch? So there are heaps of research, heaps of like information regarding this stuff, special research papers, and there's a solid research community behind all these findings. And so there are so many causes actually, just like things like Stanford has an amazing course called CS224N, CS321N, like that's like pretty much public. You can find them on YouTube, all these lectures. And then also like these online learning platforms like Coursera and everything. Like deeplearning.ai is one of the best as far as I know. But yeah, a lot there are a lot. And can we build this from scratch? Obviously, yes. Of course, yes. But it would be so expensive, like to create a not a like ChatGPT. They say like it has 175 billion parameters. No one knows. It's not open source, but there are open source models as well. So say like right now, to create a smaller model like around 7 billion parameters. So we call these models, we kind of, when we talk, it's like like light years. When you are talking about a space, we always talk about like light years, right? Like billion years or whatever it is. But like that, when we talk about large language models, we talk about number of parameters. So smaller the number of parameters, it is easier, but still to train a 7 billion model, it would take like around $2-3 million. But there are areas, like, for example, I work in fine tuning them. So I actually train them with clients' data and all. But the big question is, can we do it in a very cost-effective way? That's like the billion-dollar question right now. But yeah, surely you can do it. And I also encourage you to work with platforms like Hugging Face, Transformers, and everything. Yes, there's a hand raise from who's that? Suranjit. Yes, you have a question? You can.
Yeah, can you hear me?
Yes.
Yeah, I think because sometimes my internet connection was got wrong. So first of all, I like to thank you, you both, for this great discussion. Actually, I have a question about from Dr. Damayanti Madam. Uh, Madam, my question is actually how much minimum data is required for the developer of a machine learning model? So when I asked from the ChatGPT, it gave me 10 times the input features. So according to your idea, so how much minimum data is required for the developer machine learning model?
Right, that's a very, very good question. So, but actually, the machine learning model that we use can depend on the problem we are working on. And there are, I think I would like to, we usually, what I would do is I would think in terms of the problem perspective. Because, for example, I would try to see, okay, what are the amount of data I can gather? Because, for example, maybe if it is a medical experiment, you will not have a lot of people who are having that disease, but there will be many people who can act as a control. Now there I will have a data set where I have large number of positives, very less number of negatives. And also in some scenarios, I can only, it's because of the thing, for example, because of the challenge in annotating the data, labeling the data, I can have only very small number of label data. So based on the problem, I would rather select the machine learning model, but I would not really limit myself into, okay, I want to use a neural network model to solve this problem, if that makes sense.
Sorry, madam.
Does that make sense? So, because if you think like, if you have large amount of data, I can definitely go for a solution like neural network. But if I don't have that amount of data, what I'm trying to say is I will not I will not try to pick a machine learning model and see what number of data I should have, but rather I would look at the problem and I would select an appropriate model, if that makes sense.
Yeah, yes, madam. Yeah.
Yeah. So then, for example, if I have if I have only lot of data from only for one belonging to one class, let's say I don't have many patients with the disease, but I have many control samples, I can go for an approach like one class classification. So there will be different approaches, different machine learning models I can use. Kyle, do you have anything to add to that?
Yeah, it is very much problem dependent, like,
Yes.
so if you want to kind of domain adapt a language model or something, you probably need a lot of data. Like, for example, scale of the data sets that I work on is around 250 gigabytes. That means in token wise, 150 billion token, like in billions. But if you want to kind of fine tune, like adapt to a specific task, we call it fine tuning. That could be pretty much done by using a small scale data set around 100 million tokens. But it is for NLP, but other tasks for machine learning, it's, yeah, you can find models that would work with quite a few data points, but it's very much problem dependent. I can't give an answer for that. So you actually need to do evaluations. Like, for example, there are things like overfitting, underfitting, bias variance issues. So you need to like first train a model and see how well it performs. And if you feel like your model is overfitting or something, then only you need to um, keep increasing your data set. Yeah, it is very much problem dependent. Yeah, I agree with Dr. Damayanti. So there's another hand raised, like
So
Shamil
my
Lepirimon.
question is
Yeah.
not over actually. I have so many
Sorry.
questions.
Okay, okay.
So currently I'm doing my master's in China actually. So actually I have not good so much background basic knowledge about machine learning because I did my bachelor for the civil engineering. So for my master's degree in here, I'm doing some developing machine learning. So I'm just get started to learn about the machine learning. So for my research, actually, I'm is asked from my research. So I'm doing my research work related to machine learning with getting some three models, random forest and support vector machine and the XGBoost. So my research work is some uh, uh, how can I say? So predict the soil moisture. So so I'm collecting data nearly 1 year growing period. So after end of my data collection, nearly 10,000 or less than 10,000 data can be collected for my research work. So according to your ideas, can my research work, my machine learning model will be success in doing this way?
it's I mean, I can't say that, like, whether, because this is an empirical field. It doesn't matter you do civil, you do computer science, or you have a PhD. You can't say like it would work or not. That's why we call these areas as empirical mathematics. It's not analytical, more like numerical methods. So we let the computer to figure out a solution. But what I would do is I would follow a general set of guidelines for this kind of a thing. So I think what you're doing is correct. Like um, you need to collect certain amount of data first. You need to have your data. It could be some sort of a regression or a classification related to the soil. Then what you can start is, since you are new to this, obviously you can start with simple machine learning models. Like as you mentioned, what you are doing is good random forest, or then even support vector machines. So for this stuff, you need to first come up with a method to extract features, right? And those
Yeah.
features would be pretty much domain specific. Like you should know what are important and what are not. And
Yeah.
yeah, then you can train. But it is okay in machine learning. You don't need to afraid of whether you won't get a bad model or something. It's not like a software project that if you code it incorrect, you will get bad results. It's just like, even if you do everything correct, you might get bad results. And it's all about like kind of being creative and answering questions. So yeah, it's just like you don't have to afraid of like whether it would work or not. It will definitely work at some point. Even if it won't
Yeah.
give the 99% accuracy in the first go. But then it's all about, as I mentioned, understanding what you did, understanding what is happening, and then yeah, moving further with your experiments. Yeah, that's pretty much it.
Yeah, I think if I
Okay.
can quickly add something to that, because if we could answer that question, we are not, again, we are looking at in terms of a classical problem solving approach. Because if I say yes to that answer, what I'm saying is, okay, you have these rules, you have the data, now you know the answers as well. It doesn't sound like a scenario to use machine learning in the first place. Looks like it can be solved in the traditional manner, right? So that is one thing. And the other thing would be generally, I think going forward in any problem when you're trying to use machine learning, we try to see how much improvement will I be bringing into the current process, the traditional process, by incorporating machine learning. For example, and for example, this predicting soil moisture, maybe we are not doing it 100% for all the scenarios, but we will be able to do it with a decent accuracy for a set of selected scenario, which can have an effect on our overall process, because we are now somewhat reducing the manual processing, the manual decision making by incorporating a machine learning model. So those would be the sort of advantages, the effect that we'll be seeing through adopting a machine learning model. Does that make sense?
Yeah, yes, madam.
Yeah, and there's one question. Do you know any efficient tool to do load forecasting on power systems? I think when it comes to forecasting, we are always talking about series data, sequence data, time series data.
Okay, time series.
Sort of data. So then now again, there we can identify what sort of data we are working on. So if it is time series data, we know if there are traditional statistical models like ARIMA, SARIMA we use for these data. But if in terms of machine learning models, we go for neural network based models. Again, there are specific neural network models we can use for time series data, like recurrent neural networks, which are coming with considering the sequence effect to, because in forecasting, we are specifically considering one point. We consider the points coming before that as well. The value yesterday, day before yesterday, likewise. We are taking a series of data. So something like recurrent neural networks, or there are 1D convolution neural networks are also considered for to be used for with time series or sequence data, would be a good starting point. It's not really a tool, but a model that we can consider.
Okay.
Yeah.
There's another
Okay.
hand
Thank you
raised.
very much.
Yes.
If you don't have any problem, can you send your email to the chat box? Really appreciate it.
Yes, and thank you for that question. So I was
Okay, thank
hoping
you.
to kind of anyway, to share this. I have like this bit.ly link where you can give feedback to us. And also this is Shamni's LinkedIn. I can give Shamni's. Can you put your email quickly, Gael?
Yeah, I prefer LinkedIn message.
Okay. Yeah,
Yeah,
I think
just
it's very
drop
easy to
me a
catch
message.
him on LinkedIn. So if you go
Yeah.
to LinkedIn, this is his profile, and this is the link to my profile where all my contact details and everything are there. So we would love to be connected. And at any point, if you have any feedback around this session we did today, that would be very helpful for us too as well.
Yeah.
Uh,
There's one more question,
yes.
like Chamil.
Can I
Yeah.
come?
Go ahead. Yes, please.
Yes.
Go ahead.
Yes. Thank you. Thank you very much to both of you on behalf of the participants. Actually, I must thank you sharing this knowledge with us. With a person who is with zero knowledge of machine learning and these kinds of models, actually, when I am listening to your speeches, your lectures. Actually, what I thought was that I'm from a power and energy background, so that we have a issue with renewable energy integration to the grid, national grid. So let's say for a solar power plant, what is the main challenge is to predict the weather, and then to have other power plant set to cater if, let's say, a cloud goes nearby, and if there is a rain comes after, let's say, 1 hour. So what we need to do is to make sure the other maybe thermal power plants, maybe hydropower plants, maybe some other windows, something like that, we can be dispatched. So we need to predict the weather, and then get all these into our database, and then dynamically it should get into the let's say some control center or something like that. And after that, we do the decisions. We let's say within next 1 hour, this could be the weather, so that maybe there is 1,000 megawatt of solar, but it could be 800 megawatts. So the 200 megawatt we have to be ready in order to provide the supply. So in that background, I must forward this question to both of you. Which machine model, or let's say we need to get this data and learn first, and how long it will take to learn and gather the data and do the machine learning, and also which models that we can use to predict the weather, and then do these decisions for which I think it will be very beneficial for the dispatching purpose of the power plants. Thank you very much. Dr. Damayanti, are you not clear with that?
Yeah, no, I get your question. So basically the idea is, I think if I try to summarize the question, we are now operating this particular plant, a power plant, maybe based on any source. And now I want to predict what is the, what could be the output, power generated from this, right? That's the sort of question.
Exactly. Yeah.
And what can I use? So actually, this is a very common question that is being looked into. And if you look at, there are a lot of research papers. Even I have published this in like forecasting electricity power generation of this particular Pawandana wind farm in Sri Lanka. But here I'm using a different approach compared to machine learning. So the straightaway answer to your question would be, in that case, we will be looking at machine learning models that can handle sequences, because we are looking at sequence of data. It is like I have n number of data predicted for the n+1. And that n+1 is not only depending on the data at n, it can depend on the data at n-1 as well. That is what is meant by sequence of data. So I will need machine learning models that can handle sequences. This is where, and a lot of the time we go for neural network based models. If you have time series data, and also sometimes you can use maybe derived features from weather data. It's not really exact the rainfall or the sunlight, what we have like sunlight or whatever that, but we use derived features. So we can you can go for like something like a neural network that can handle sequences, or if you have derived features, we can go for a very traditional machine learning models like these tree-based models, linear regression models, etc., etc. But at the same time, I think you also raised the question about the data. But what I have learned with the little amount of work I have done is there is already available data. I think meteorology department can give us this data, isn't it? So
yes.
So we don't really have to gather this data. I think we might have to pay, or we might have to some way convince them, rather, not really even pay, but convince them to give us this data. And then we can build models based on this data, because now we are looking at this special geographic location called Sri Lanka. And then we can gather the previous history data around our the power generation of our plant, and then we can merge these data to develop to train machine learning models. It's not really, I think the question is not really about identifying what is the best machine learning model, but rather it's, I think we have to spend a lot of time about understanding the sort of problem that we are dealing with. What are the factors that we are dealing with? And then if we develop a machine learning model, how much of our overall process can be automated? what is the effect it's going to have, how much accuracy do I need? Can I get away with 60% or so accuracy, or it's very critical? Should I have 98% accuracy? Or now at the moment, I'm using this traditional method to do this forecasting. How much profit I will gain if I move to a machine learning model? And even it's not, we can just deploy it once and be happy forever. We will have to keep updating these models as well. We will have to retrain this model with new data because the dynamics will change as we go on. But it's also an advantage of using machine learning for this sort of a scenario, because we can easily adapt to that changes as well compared to the traditional approach. So I would say it's not really about picking the correct machine learning model or training them. It's not anymore. It's not about that, because we have access to computing power. We will probably have access to the data as well. If you can, pull the correct string, talk to correct people, you can get access to the data as well. But I think now a lot of focus should be around understanding the problem. Does that answer your question? Give some idea?
Yes, Doctor. Yes, pretty much. Thank you. Thank you very much.
Yeah, thank you for that question. Are there any other questions? So I think we have taken almost 2 hours. I think we are like reaching the limit of our concentration as well. So what I would suggest is we will leave it. If you have any questions at any point, not at today, but in future also, if you want to clarify anything, please feel free to drop an email to myself or Gayal, and we would really happy to help you. And I think we can wind up.
Yeah, Dr. Damayanti and Dr. Shamil, thank you very much. And on behalf of the physical audience, there are a lot of questions. I mean, the session was very interesting. People are having a lot of questions. So just to give a justification for them, I will put one question on behalf of them. So so we discuss about application on OpenAI. So now there are a lot of competitors for the OpenAI like Google, Microsoft. All I know, we know that currently Google Bard and Gemini is also coming to the picture. So what are the difference between those platforms or tools, and how the practitioners can get maximum benefit out of them?
I think Gayal is the best person to answer that question.
Yeah, I mean, so if you talk about this technology of transformers, it was introduced by Google around 2017 with the paper called BERT. So obviously Google has all the theoretical knowledge and everything, if I want to explain it that way. But I don't know, my personal opinion is OpenAI, they have already won this race. Like it's a done deal for me now, because the thing is, the harder part would be to have a, like, in order to even to host a huge model, you need to have some kind of a very specific infrastructure, and also these training routines and everything. It's hard. So I have feeling like OpenAI is like the Google search engine. You know, when it comes to search engines, Google is there, Yahoo is there, MSN is there, but we always we like Google, right? So OpenAI, when it comes to LLM models, OpenAI is pretty much in the top notch, because it's all about the data as well, because they have been using our data to come up with their new version. So it's just like, it's what I would say is, like, theory wise, Google, Microsoft, obviously they have a lot of knowledge, but somehow OpenAI managed to make it work as the first bunch of people. So they are pretty much ahead of the game, but it's really hard, like, to say which one is better. But what I would usually do is kind of see these benchmarks. So we have these things like MTB benchmark, massively multilingual task evaluation benchmark or something. From all these things, at this moment, ChatGPT is like the mod. Like ChatGPT is like the best. Then comes the other things, but I have actually used all these paid things for like a month. I just wanted to try. For me, the best one is ChatGPT. Like OpenAI solutions are the best at this moment. Yeah, but yeah, it could change in the future. But right now, OpenAI is the best out there. Yeah.
I would like to quickly add, I think we both must mention that this is the picture we are seeing today on this 29th of January, and maybe 30th of January, you might see a very completely different picture. There can be, you know, a giant appearing and saying that, okay, we have got the best generative AI tool. That's one thing. The other thing is, it's also about general purpose versus specific purpose, because you might be looking at a very specific purpose, and then there can be like a tool that is, for example, Quillbot or something like Grammarly or GitHub Copilot. It is now would be very more convenient for you to use rather than directly using ChatGPT, I think, because it's very task specific, and it's developed in such a way, implemented in such a way for that particular task.
Right. Thank you very much, Dr. Shaman and Dr. Damayanti, for this comprehensive, informative, and useful session that you conducted. I think we spent more than 2 hours. That gave us the implication that how much you have added to the context. So I think within very short notice, both of you accept our invitation on behalf of Electrical, Electronic and Telecommunication Engineering Section Committee. I should pay utmost gratitude, and I should be thankful for your contribution and the commitment given to improve the knowledge of our membership. Especially, I think Dr. Shaman is joining from USA. I think it's over midnight for him. Hi, Shaman. I think thank you very much.
Hi. No, yeah. It's Auckland. Yeah. It's 3 a.m. But yeah, I wouldn't complain. I kind of can start my work early because I work with the US team. So my entire team is in US and Canada. So I can, because it's the summer as well here. So I might finish my day around 9-10 today. So yeah, I might not complain. Yeah. Sometimes I like to get up early. It's okay.
Great. We really proud about you. I think he's a very young scientist and engineer, and he has done a lot to the industry during this very short period of time. And I think we cannot stop this discussion at this point. A lot of information, questions, and queries are coming for us. So I invite all of you to follow their social medias and LinkedIn profile so that you can keep in touch with them and ask a question, and they will support you throughout this journey. And we also like to work with you again, Dr. Shaman and Dr. Damayanti. On behalf of ISL and Electrical, Electronic and Telecommunication Section Committee, I should be thankful for your commitment and the contribution given to success this session. And we would like to work with you again. Thank you very much, both of you again. So for all the audience, I think we all had a good discussion and a productive session. So please forward your ideas and suggestions to us, and we can further improve, and we can arrange this sort of seminars and discussions in future. So thank you very much all for joining with us for more than 2 hours, and have a good day. Good night.
Okay, bye-bye.
Thank you,
Thanks.
everyone. Yeah, it was very lovely to meet you. So have a good evening. Thanks.